All right, 451. So, on, what was that? December, before Christmas break, we were sketching graphs. We had this equation, y is equal to mx plus b. What does m represent? Slope, which is what over what? Rise over run. Okay. What does b represent? The y-intercept. Okay. If you're going to graph a line, always put it into y is equal to mx plus b form. It's the easiest form to graph. Okay. This unit is about graphing, but we're using lines to solve equations. So we're going to have, it's called systems of equations. So let's just go down here, down to the bottom here. I'm not going to worry about the actual question. It's a word problem, but I want to solve, I have this line and I have this line. I want to know where they intersect. That's what I'm at. That's what they're asking. All right. Where do they intersect? Okay. So are these linear lines? How do you know if they're linear or not? Exponent of 1. And they're all exponents of 1, right? Okay. And this is math 10, and we only do linear lines. So if I want to graph this, what do I have to do? What form do I have to write it? Y is equal to mx plus b. What's the easiest way to get it into that form from the way it's written right now? What am I going to move? Move the 3x over. So I've got that. 11 minus 3x. Okay, let's sketch that line. What is my slope? Negative 3 over 1. It is negative 3, but I'm just going to write the over 1. And what's my y-intercept? 11. So to sketch the line, you go to 11 on the y-axis, which is the vertical, which is right there. That's your first point. Then what do you do from there? Down 3, because remember, slope is rise over run. So I go down 3, 1, 2, 3, and over 1. And I draw the line. I'm going to do. Let's see if I can actually draw a straight line. I got a ruler right here, but oops, why are we not drawing a line? Freehand, here we go. There's my line. Hopefully yours is better than that. Okay. Now I have to do the other line. This one. What do I do to get this line, 2x plus 3y is equal to 12, into mx plus b form? What's my first step? I'd move the 2x first. I'd move the 2x over. So I get 12 minus 2x. And then divide by 3. But you have to divide everything by 3. So I get y is equal to, what's 12 divided by 3? And then leave it in fractional form. So there's my equation. What's my slope? Negative 2 or 3. What's my y-intercept? 4. So now I find my y-intercept. 1, 2, 3, 4. And I go down 2 and over 3. 1, 2, 3. Oh. And if you draw a line like that, where do they intersect? Yeah. 1, 2, 3, and up 2. So they intersect at 3 and 2. Oops. That is the answer. Where the two lines intersect is your answer. So what does x equal? X is 3 and y is 2, because it's always written xy. So you could say x equals 3, y is equal to 2. So the answer to where do these graphs intersect, or what is the solution of this system, is just 3 and 2. Is that okay? Going once, going twice. All right, next page, please. All right, bottom of the next page. So we have a new system. 2x plus y is equal to 2. X minus 3y is equal to 15. Let's solve this system. So the first thing is to graph it. All right, what form do they have to be in? mx plus b. Has to be y is equal to mx plus b. So what am I going to do the first one, this one? Oops. Move the 2x over. And what about the next one? What should I do? What do you want to move? What do you, this one? How do I want to move it? Manipulate it. Move the y? Okay, then it makes it positive. So I'm going to move the 15 over to the other side, right? So I'm going to get x minus 15 is equal to 3y. Now what? Divide everything by? What number is beside the x if no number is written? 1. So I can write it as 1/3 x. 15 over 3 is? 5. So there's my two equations. So now when they say solve it or state the solution, graph them, find where they intersect. Go. I'll freeze it and I'll put my answer up and we'll see if we get the same answer. So just like we did in the front page, x-intercept, y-intercept, graph the lines, where do they intersect? I didn't freeze it, did I? Is that what people got though? Sorry? 3 and negative 4, yeah. Are we okay with that? All right, there's a way to check your answers too. So, when they say verify, it's up to you, but what you do is you take your x and your y, this is your x, that's your y, and you can plug it into each equation to see if it makes it a true statement. So if I put my x into x, 2 bracket 3 plus negative 4 into y, what's 2 times 3? 6 minus 4. What's 6 minus 4? Does 2 equal to 2? Yes, so that is an acceptable solution. And you can check it in the other one as well. X, which is 3, minus 3 times negative 4. Negative 3 times negative 4 is 12. And you get 15 is equal to 15. If you get it, so it's like negative 5 is equal to 15, you know you've done something wrong. Okay, you want to make it so that where you substituted in equals the other side. And that's just a way to check your answer. Are there questions about that? Sketch the graph, and that's pretty much it. We okay with it? Okay, here's what I'd like you to do. Questions 1, 2, and hang on. 3, A, C, and E. 1 and 2, just do the part where it says graph it. It might say use graphing technology. Don't do that. Just sketch it by hand and do that. And I'm going to print off some graph paper so you can do number 3. Okay. So, if I ask you to graph this, all right, these lines are already written in mx plus b form. So for the first one here, the slope, what's the slope here of this one? 1. And the y-intercept is 5. The second one, what's the slope? M is equal to negative 1, and the y-intercept is 1. So if I was sketching them, and it doesn't have to be accurate, okay? So if I was going to sketch the top one, x plus 5, I have a y-intercept of 5, and a slope of 1, which means I go up 1 over 1. I'll just say it's there. There's the line, okay? If I do the second one, I have a y-intercept of 1. We'll just guess and say it's there. I go down 1 and to the right 1 because my slope is negative 1. How many solutions does that have? Where do they intersect? How many times? Once, right? So this has one solution. The next one. What is my slope for the top one? 2x minus 8. It has a slope of 2 and a y-intercept of negative 8. If I was going to graph that, the y-intercept of negative 8, I'll just say there's negative 8, and a slope of 2 up 2 over 1 looks like that. The 2x plus 6 has a slope of 2 and a y-intercept of 6. So if you were to graph that, y-intercept of 6, I don't know, there. Slope of 2 up 2 over 1. Looks like that. Do those lines ever intersect? Why not? I heard the word. Because they're parallel lines. They have the same slope. If they have the same slope but different y-intercepts, they will never intersect. So how many solutions does it have? 0. Or you would say no solution. All right, last one. The first one's already in mx plus b form. So I know m is equal to 3, and the y-intercept is -2. So -2 up 3 over 1. Oh, there's a line. What do I have to do with this one? Can I graph it as is? Okay, so I'm going to move the 2y over first. And then what am I going to do? Divide by 2. And I get, what do you notice? It's the same, right? 3x minus 2, correct? So if I was going to graph this one, it would be right on top of this, correct? So how many solutions does it have? An infinite, or there's infinity solutions because they're lying right on top of one another. Okay? So there's an infinite number of solutions. All right. So we're going to summarize this in the table, and then I'll give you a couple questions and we're done. So if the lines intersect at one point, so that means the graphs look like that. Okay? You have one solution. For what? SOL apostrophe N, you can say that. Like this. Okay, what do you notice about the slopes and the y-intercept? So let's look at this first one here. Are the slopes the same? No. No. Are the y-intercepts the same? No. No. So slopes are different. Y-intercept different. If you have different slopes and different y-intercepts, you have one solution. If you have slopes that are equal, but the y-intercepts are different, so they look like this. Y-intercepts are different, but the slopes are the same. They look like that. They're parallel lines. How many solutions do parallel lines have? So there is no solution. And there are infinitely many solutions, which means the lines are on top of one another. And that is same slope, same y-intercept. They'd say those are coincident lines. You don't have to worry about that. You can just say they have infinitely many solutions. All right. I just want to do one question, and then we're done. So A here. Tell me if there's infinitely many zero or no solution, or one solution. So, peoples, please be quiet. Put everything into y is equal to mx plus b. This one already is, okay? Because it's y equals. But this one is not. What do I have to do with this one? What should I move? Move the 3x. Yeah, that's correct. So I move it to the other side. Divide by 5. (15/5) is 3 minus 3/5 x. Okay. Now these are the two lines I'm comparing. What do you notice about the slopes? They're the same. So they have same slope. But now look at the y-intercepts. Are the y-intercepts the same? No, because the y-intercept for this one, b is 0. The y-intercept for this one, b is equal to 3. So if you have the same y or different y-intercepts but the same slope, how many solutions do you have? None, because it's this one. You have parallel lines. Okay? So if they ask you how many solutions, put them in y is equal to mx plus b form. Look at the slopes and the y-intercepts. Look at these tables. No. All you have to do is go like this. You don't really have to memorize them because if you have them like this, Emma, if you have it like this, you can just do a quick sketch. That has a y-intercept of 0 and a slope of -3/5. This has a y-intercept of 3 and a slope of -3/5. So you know the parallel. All right, that's all you have to do, really. Okay, the only question I want you to do is number 4. Please.